Hello everyone, my name is Vince Hammond. I'm your host for this next session in Lisp training for DraftSight. This is session 6. For those of you that have not gone through the other sessions, I'd highly recommend, if you have not, you should really go back to those previous sessions, especially 4 and 5, because everything we're covering today is going to be based on things that we learned in those previous sessions. So just a quick review. What did we cover last time? In the previous session, we went through selection sets. I did a deeper dive into entity selection, entity tables, and how to grab that data out of those entities. And then conditional statements, how we can do, and conditional functions, and how we can do if and while and repeat loops, things like that. We also did a little bit on data tables, looking at blocks, which sort of brings us into what we're going to cover today. Now, in this session, I'm going to do a deeper dive into block management and attributes, how we can assign attributes, how those things are managed, also how we can extract that data, those attributes from the drawings. And then I do want to cover an alternative to attributes, just so you have it as an option, especially if you get deeper into some of the data management things that you want to do with Lisp. You may find cases where you would want to use something like extended entity data to do that. And then finally, we'll go through a little bit of file editing and how that works, how we open and close files, how we read and write files externally, and then also just a brief glimpse at some of the things that we can do with ASCII data and why that's important. So to get started, let's go into block management. Now, if I look at the command sequence that I'm going to use for inserting a block, what you'll find is, first of all, we use a -insert function, which presents the command without the dialog box. We have to present the block name for that block, the insertion point, an X factor, a Y factor, and then also a rotation. So this is pretty much the sequence we use when creating a Lisp function to insert a block. Now, an example might be a title block. For instance, maybe I want to insert a title block. Well, if I create a function to do that, I'm simply going to put in the name title block. I'm going to pause for the location. And then when it comes to X, Y, and rotation angles, you'll see that I can just simply put those values in for that block. Now, when we create functions in Lisp to insert blocks, one of the best practices that I did cover before, but I want to go through it again, is to make sure that we add the block folder to our support files. And you'll notice here in this case I use the user's public folder, and then I have a DraftSight folder, and then within that folder I have a folder for blocks, and that's typically where I might keep my highly used blocks, things that I'm going to use over and over, for instance like a title block. And again, you can move those up and down, and the way DraftSight works is as it searches for this title block, it will, if I specify it here, it will look through all these support folders first before it will give me an error that it cannot find it. So a couple things about blocks. I know that they tend to be one of the subjects I cover more in a lot of CAD training, and there are a lot of questions around that, and there's some confusion, and I do answer a lot of support questions around blocks or see a lot of times where blocks are not created properly. So a couple of my golden rules that I have in terms of block creation. Number one is if you create a block and the objects in that block are on layer 0, when you go to insert that block on any layer, it will take on the properties of that layer. Now, if you create a block and the objects inside the block are not on layer 0 and they have a color assigned to them, you cannot overwrite those colors or those properties because those are then inherent in the block. So just one of those things, if you want to have flexibility, putting things on different layers. Sometimes we have, for instance, in construction, you might see an example where someone will put something on a layer that has to be demoed and something that's new or existing, and they want the same block and they want to put it on those 3 layers and have it represented by 3 different colors. The only way that that's going to work is by that initial block definition having the layer 0 is the objects being on that layer 0. So just one of those things. The other thing that's very important is when you create attributes within that block, the order that those attributes are created is the order that they will prompt when that block comes up or when you go to insert that block. Now, you can change the order, and the way you do that is when you create the block, or when you use the WBlock command to export the drawing out or that block out to a drawing, the order that you pick the objects, so you could pick the objects and then pick the attributes in a specific order, will be the order that they will show up when you get the interface or the dialog box. Something to keep in mind. Now, another area that is one that I like to cover in training around blocks is around the command called WBlock. Sometimes there's some confusion around that, but I like to always explain it this way. The WBlock command is actually a verb, not a noun. There is no such thing as a WBlock object. So what happens when we use the command WBlock is it basically creates a drawing. And I love the fact here that when you type in WBlock in DraftSight, it actually tells you that. It says export drawing. Because I think there's some confusion around that. People feel sometimes that the blocks are actually different types of objects, but any drawing can be inserted into any other drawing, and when that action happens, it becomes a block within the drawing. The only other option there is external referencing. Now, in this case, we're not going to talk about external references, but working with blocks, like I said, anytime we take a drawing and we bring it into another drawing, it then becomes a block within that drawing. Very simple. So, now, when I talked about this earlier with the attributes, they come in order based on the order that they are inside of the block. So if we use this command insert title block or whatever the block name is, we have an insertion point, X, Y, and rotation. The attributes then will be prompted on the command line in the order that they are within the block. So an example might be, like I used this title block example, as we go to insert it, the sequence is very critical when it gets down to the point where it starts to answer the prompts for the attributes. So now let me just jump over to DraftSight real quick. I do have a title block here. In fact, let me go ahead and open it up. In this drawing, you'll notice I have 5 attributes, and these are defined within this drawing. Drawing title, drawn by, date, revision, and scale. And so when I go to insert this drawing, this title block, into another drawing, those prompts will show up in the order, the attributes will show up in the order that they were created and or saved inside of this block drawing. So let's talk about creating a function or a command that will insert the title block into our current drawing. So to do that, we're going to define a command. We're going to call it title. And then you'll see I'm going to set a number of variables. These should look familiar to you. First of all, we're going to get the current, we're going to use a getVar command for login name to get the current username. We're going to set that to a variable called login. And then you've seen this before. This is grabbing the current date, and then we're going to string it together in month, day, year. And then another variable that I'm going to grab is something called cLayer, getVar cLayer. It's going to, I'm going to set the variable old ly to the current layer before I make any changes. So this is really good practice to grab current settings. Sometimes we grab old layer, the current layer, maybe it's snaps, other things. This is just another example of when I do this, and you'll see at the end here we're going to restore that layer when we're done. So the first command I'm going to do after I grab my or set my variables is to create a layer called title. Now in this case I'm not going to specify color. It's probably by default it's going to come in as white, so we'll just say make layer title, and then I'm going to set a variable called attdia to off. Attdia off is really that prompt or the toggle that prevents that prompt for the attribute dialog interface from showing up so that we can answer the questions on the command line. So when we look at the sequence, you'll see insert, title block, insertion point, XY, rotation, and then we're going to, in this case, I've specified with a comment line to note the attributes that are going to show up in the order. I'm going to pause for the title. I'm going to put in the login name, the date, and then the revision and the scale. Now, these could be predetermined or could be defaults inside of those attributes, but in this case, I'm actually forcing the value in. So you could always change this and override whatever the current value is for those attributes. Now, the next thing I will do is I will then launch a command called attedit. And if you remember in the last session, we have a way of picking the last entity drawn in or created in the drawing, and that's by using ent last. So this will actually launch the attribute editor. I like to do this after I've created a block and I put some information in it. Sometimes you want to double check or give the user an opportunity to make some changes. So you can do this. This is, again, it's optional. You could always comment this out. You wouldn't need to do that. And then finally, we take that variable called old ly, and I set the current layer to the old, whatever the layer was before running this command. We set it back, and then we turn the attribute dialogues back on after we're done. And then the final thing there is the print C to get rid of that little nil statement at the end. So that's my function, or my command function, called title. And the other thing that we did talk about last time, if we take a look at our startup, is I explained about demand loading. And so this is another example where I might want to do a demand load. I might say, okay, define a function called title. And if someone says title and types it in, go ahead and load that and then run the function called, or the command function called title. So let's go into DraftSight, and I'm in a drawing, I believe. Let's just take, I think I have a drawing I started, a blank drawing that's got a sheet of paper, or, basically a rectangle representing this. If I'm in the drawing now and I type in title, you'll notice that it automatically comes and asks for a title block. In this case, I'm going to pick an endpoint. And down here, you'll notice it's asking me for title. So I can say, we'll just call this a sample drawing. And you'll notice it populated the rest of the information and put in my name, the date, the revision, the scale, and then it prompted me with the attribute editor, basically just as we had in the original program. And we say OK, and notice down here the nil doesn't show up because we did that. So quite simple. Just an example of how you can create a function to insert that information and populate with the date, time, other information all automatically. A couple other tips I like to go over in terms of blocks is what happens when we go to insert a block or try to insert a block into a drawing that already has that block definition inside. Now, the way this works is if the block definition is there, the definition within the drawing is automatically used unless you specify a path. If you say bring in this block from this specific location, in that sense, DraftSight will automatically warn you that you're about to overwrite the block definition that is in the drawing. Now, depending on the CAD system you're using, sometimes these things are prompted, sometimes they're not. So I always encourage people to go through the sequence of events and test it on a drawing that is typical to make sure that you got the sequence down correctly. Now, in this case, I just wanted to bring up that there's something called set command prompt level, or it's known as expert mode in other CAD packages. In DraftSight, this expert mode does not suppress this warning, so we have to know when this warning is going to show up in order to make sure we get the sequence correct. I know that this set command prompt level does suppress other drawing overwrite warnings, but it does not for the block definitions being overwritten. Now, if we want to force, let's say, for instance, we have drawings that we want to go into and automatically update the blocks in the drawing with a more current version of the block drawing that we've created. We want to bring that in and we want to overwrite it. We can use a sequence called block name equals file name. In our Lisp routine or in a script file or in our macros, we have to use this block name equals file name. And what happens when we do that, in fact, if we type minus insert at the command line and we go in when it says block name, if we type, like in this case I have a joist, if I type in the joist equals the location of the joist as a DWG, it will prompt us does it already exist? Do you want to read it? Already exists. Do you want to redefine it? Yes or no? So very important, because that does change our sequence of events. And so as you noticed last time, I said there were examples of there are cases where we might want to do a table search to see if a block exists. Well, here's a good example. If we do table search block title block, if it already exists, then go ahead and do an insert title block equals title block and answer yes to that question. Now, this a sequence here I'm doing a little different that I wanted to show you, and that is by doing this block equals drawing name event and then answering yes, and then ending the command and not answering the rest of the questions but putting in a command, I'm actually canceling out of this command. So command within parentheses is this without any arguments is the same as hitting escape or cancel on the keyboard. So good to know. This is sometimes a sequence we use. If I want to update the existing blocks within a drawing, I can do this sequence and then not have to be forced to insert. Some people will insert it and then erase the last object, but I tend to just there's multiple ways to do that. But here I'm just going to use a command to cancel out. The way this command will work is it will overwrite yes, but then when it comes to inserting, you're basically canceling out of the insert, so the redefinition has already happened. Now, something to keep in mind, if you do this sequence of events to overwrite or update blocks within a drawing, it will update the blocks, but it will not update the attributes. So there's a command called update block attributes within DraftSight that can be used to synchronize or update attributes that are in blocks. And oftentimes we see this where I might get a drawing that has a number of blocks that are missing attributes. Some blocks have the attributes and some of them are missing the attributes, and oftentimes that happens because there was an older version and then that block got updated later on in the drawing's lifespan, and the older ones were never synchronized or updated. So sometimes that's something to look for, or that could be an area that has to be sort of looked at. Now let's talk about attributes. What about how do we create them, and what's the sequence events to get the data in there and or retrieve that data? Now, a couple things I wanted to point out about attributes. First we create a block, and then we use a command called ATTDEF, attribute definition, to create an attribute that we place within that block. And when we do this, it's going to ask for a name, a caption, and a default value. Now, the one thing I do want to point out is you do not ever want to use spaces in the name. This will cause you all kinds of problems later if you try to do any kind of extraction, any type of extraction things. And so be very, very careful about the attribute definition, the name of the attribute. Whatever you call that, don't put a name or any special characters in there. You could use a hyphen or an underscore, I think, but for the most part, I would try to keep it as clean and short as possible with without using spaces. So once you've created that attribute, then you use either the block command to combine your block, to create your block, or the W block command to create the drawing, and you go through the sequence of selecting the entities and then finally selecting the attributes in the order that you want. Now, I did want to point something out. Let me just bounce over here to DraftSight real quick and take a look. I do have a title block. If we go to do ATTDEF, when I go to place an attribute in the drawing, there's a couple behavior options that you have here. And one of the best practices I have is the only one I ever use, other than the default setting of having none of these on, is hidden. Sometimes you might want to have a hidden value within your title block, within a block. Maybe it's a part number. You want it associated to the block, but you don't want it to be seen. You can create that as a hidden attribute. There is a way even if they're hidden, we can force them all to be on so we can see them. But this is very useful, in terms of creating a hidden attribute. However, fixed, I'm not a fan of fixed because it's basically something that can't be changed later. And predefined, you have a default value that you can put in. So predefined it's almost redundant, but I don't think I would necessarily use predefined. Validate is one I don't know why it's in here as an option, because it just forces you to answer the question twice. I just don't think validate is a good option here. I just don't use it. And then multi-lines, I think this is, if you want a multi-line text and you want to support that, you can use multi-lines for that behavior. And you can get into that in more advanced attribute types of setups later. But for the most part, if you're just doing some simple things, I would try to stay away from this for now. So let's go back to once we created our our block. We use these commands to export them. And then when we go to insert, there's two set var variables, and one I've already shown you. One's called that you want to be aware of. One's called attribute DIA, which is the dialog box. Do you want that to not show up or show up when you go to create that? And then there's also something called attribute request. If you turn ATTREQ to 0 or turn it off, then you will not be prompted for attributes at all when you go to insert the block. So what does that look like? And I did want to talk about this. Now, the sequence that I gave you was we're going to insert and then we're going to put in a prompt for each of those attributes. Now, what if you don't have attribute data and you just want to insert it, but you don't want to have to deal with the attributes? You just want to bring that up in a dialog box. In that case, what you can say is let's turn the attribute request off. Let's go ahead and insert that block. None of the attributes will be asked. Turn the attribute request back on, and then go ahead and launch the attribute editor on the last object created. So this is sometimes a good sequence to go through when you have different blocks with different numbers of attributes, and you don't, all of those are preset values. You don't necessarily have to ask every single time, or you don't want to take a current information like a current date and shove it in as a value to one of those attributes. So it's just an alternative method to bringing in or inserting attributes into the drawing. Once we've placed blocks with attributes in a drawing, how do we get that data out of the drawing? How do we extract those attributes? Now, it's an interesting sequence of events that we would do if we want to automate this through Lisp and or through scripts or macros. In order to do that, we're going to use a template file. And the template file is simply a notepad file. It's got a TXT extension. And the format of the file is going to have the name of the attribute that we defined, the type that it is, a value for the length, and then a value for decimal places. So what does that look like? So the type is going to be either a C or an N. It's either a character, a string value, or it's a number, a numeric value. So it's a C or an N. And then the next three characters, or we'll call them digits, will determine how long that attribute is, the value for the attribute is going to be. For example, if it's 005, it's only 5 characters, or if we want 20 characters of value to be extracted, we have to specify 020 for 20 characters. And then in terms of decimal places, now decimal places will always be 000 if it's a character value because there is no decimal places, but we do have to supply the 3 zeros. If, especially if it's a string, we have to do that. But if it's a number and we want 3 decimal places to the left, then we would supply this with 003. So let me give you an example. Let's say that drawing title that we used before. Let's say we want to extract at least 20 characters to represent the value for that string. We would say C020 and then 000 for 20 characters. If we want object length, let's say it's a numerical value we're pulling from something and it's a number that's associated, we would say N for numerical value, and let's say 8 places and then 3 places to the right of the decimal is the sequence. So basically the template file is going to look like this. For that example that I gave you earlier, that title block I created, I'm going to put in the attributes, drawing title, drawn by, date, DWG rev, and DWG scale. And then I'm going to say, okay, I want 20 characters for title, 10 characters for the name, 15 characters for the date, 4 characters for revision, and 20 characters for scale. So how does that work? We use a command called ATTEXT, attribute extraction. To extract, you'll get an interface, a dialog box that'll come up and ask you for the template. Now, there's a text file we created. Now, with this interface, we can select entities and pick just the ones that we want to extract. When it comes to automation, or if we're going to put this into a Lisp routine, we're going to specify the name of the template, but it's just going to take and look at everything in the drawing unless we create some kind of a selection set. But typically when we do this through a manual, through an automated method, it's not going to give us this prompt here. It will ask us for an output name, and then there's 2 different formats that we can use. The first is a comma delimited format, which we would use if we want to take this data and put it into an Excel spreadsheet. Or the other is a space delimited format, And this is the format that we're going to use, that if we want to open up that file and read things from it for more processing in another Lisp routine, then we'd probably want to use a space delimited format. And I'll show you why in a little bit here. But so what's the sequence? If I use this, if in a Lisp command, it's going to be command -att, and then I'm going to specify either SDF or CDF, then the name of the template file that I'm going to use, and then the report file or the output file where it's going to go to. And so, like I said before, if I use this sequence, it selects all of the objects within the drawing to export them. So what does this look like? Like I said, here's the sequence. So I might use open parenthesis command -att ext attribute extract space delimited format. Here's my template, the title block I called it, and then here is my report. I'm going to call it test-sdf, or if I'm going to do a comma delimited format, I'm going to use CDF for the prompt, and then change my output name to CDF. You can use the same template for comma or space delimited. Either one will work. So what does that look like when we do an extraction? So if I have my sample drawing and I use this template, when I extract it, if it's a comma delimited, you will see for example, if I put a comma after sample comma drawing, you'll notice that I get the comma in here, and then the other commas that separate the fields or the data will be separated by the little quote symbol. So I can easily import this information into Excel. Now, if I were to extract 1,000 blocks that have data in them, and I use the comma delimited format, every block will be in its own individual line, and so they'll just continue to go through that text file with every single one listed in that sequence. Now, if I want to be able to take this data and bring it back into another program, another Lisp routine, I want to read some of this information, because I natively don't have the ability to find what is a field or what is separated by these delimiters in an easy format, we have to use a space delimiting. And this can be a little bit cumbersome, but just if you bear with me, you'll see there's a sequence to make this work if you need to read this data back in some other way, shape, or form. Let me show you how we do this in Lisp and how we grab this data from a space delimited format. So when we did this extraction, oftentimes what I'll do is I might open up the export file and place this header inside the file just so I can get the sequence down of where the characters line up and how they line up. I mean, you can do it from looking at this. You can count them. You can say, okay, if I take 20, then 10, I would start at the 31st character and grab 15. But, in this case, it's a small file. It's not too difficult to figure out. But as files get longer and things get more complicated, you might find this little trick a little useful. So here, you'll notice that by putting in this header, I can easily go, oh, okay, the date starts at the 31st character, and then I know it goes 15 characters. And so the sequence, when I read this line in Lisp, would be give me the substring of the value of this line, start at the 31st character and go 15. And if I want the revision information, I'm going to go to the 46th character. So I'm going to do a substring, the value of the line, start at the 46th character, and then go for the next 4 characters to get that value. So just a sequence of events that you might use if you want to go back in to extract from an exported file, extract the information, bring it back in to do something else with within the drawing, within a Lisp routine. So let's talk about extended entity data. This is one of those areas where this is probably more of an advanced subject, but I want to share it with you because I think there might be cases where you find that this might be very useful, or you might think that this could be an opportunity where you'd want to do something different than using attributes. Now, what are the reasons we'd use extended entity data? Well, the first is, let's say I want to attach data or information to an object. Let's say it's a line or a circle or something else. I can't put attributes on objects. I can only put attributes on blocks. But with the extended entity data, I can attach that to anything, whether it's an object or a block. Doesn't matter. I can use Lisp to grab the information. I can put it on the object or retrieve it from the object. I don't need to use all these template files and write it out to a file, open that file, and read it back. It's a little bit easier to actually put information onto an object. Now, often I'm going to use extended entity data where I have some special cases where I want to attach additional data to a block, but I don't want to have to create the attributes or assign attributes to do that. And so there's a lot of cases where, especially when we get into some more complex things, where extended entity data really comes in handy. Now, the sequence to create this is you have to register an application. We use a function called regapp to register whatever the application name is, and you can name this anything pretty much that you want. Then what we'll do is we select an entity, we grab the entity name, and then we do what's called -3 association list. We do a substitution to replace the existing association list with a new one that has the additional data in it, and then we use finally we use a function called entmod to modify that entity. Now, the reason I'm going to just kind of run through this is because I've given you an example, and I've written an example for you that you can use that does all this in one one function, so you don't have to really know the whole sequence of events. So this is how it works. Basically, I'm going to create a Lisp function called setXData. I'm going to use an entity that's been selected. I'm going to give it a name, and then I'm going to associate the value. And this function will take whatever that value is and associate it to that entity. And it's permanently attached. So if you exit the drawing and you come back in, the next day, the next month, the next year, and you extract that information, it's still there, still associated and attached to that object. So here's my function. And I'll give you this so that you can basically copy this information to create this function on your own. So if you notice in the beginning here, we do a registration of the app, whatever the name is, and then we create the association list, and then I check to see if that association list already exists, that -3 association list. I'm going to do what's called a substitution. I'm going to take the new data and replace the old data, but if it does not exist, I'm just going to attach that data or append it to that object. And then to extract it, I'll create another function called getXData, which basically just you grab the object and you supply the application name, and it'll return for you the actual value of that extended entity data. So what does that look like? Let's just maybe take a look at an example here. Let me go back to I'll go to this drawing. Let's say it's the title block, and I want to add a piece of XData to the drawing. I'm going to simply say set X data, and I'm going to do a car and select. So we're going to grab the object, and then we're going to pull the object, the entity name from it. I'm going to create an application called Vince, and then I'm going to give it a value of 1, 2, 3, 4, 5, and that's simply it. That's my function. When I go to pick my title block, you'll notice down at the bottom here, it actually created an association list that it added to the object with the application called Vince, and the value is 1, 2, 3, 4, 5. So in order to retrieve that, we just say get XData, and we're going to do the same thing. We're going to do a car ent select. So we're going to pick on our object, and we're just looking for the data associated to the application called Vince, and I pick on this, and it should return the value 1, 2, 3, 4, 5. So it's just another method, and what I've given you is two functions that you can use, this function and this previous function, to associate data to an object and then retrieve that object. It could be a block, or it could be simply a line or a circle or anything that's in the drawing. It's just something to think about. It's an alternative method. and it's a little bit more complicated, and you can kind of see there's a lot of parentheses in this code, but if you sit down and study it, it's actually not too difficult once you get into it. But I think it might be a good example that you might be able to start thinking of different ways of attaching data to objects within the drawing. So let's talk about editing files. What can we do with external files and how can we edit those? So the function we use to edit external files is simply open parenthesis, the command or function name called open. We supply a file name, and then what is the operation that we want to do with that file. There are three operations that we can do. The first is read, which is simply R, W is write, and A is append. Now with write, if the file exists and you go to write, it completely overwrites the contents of the file. Basically wipes out the file and rewrites the file from the beginning. If you use append, if there's data in that file, it'll just append onto the file. Now you can also use append if the file doesn't exist, it just creates a new file and adds the data to it. It doesn't have to exist for append to work. So what's an example? Let's say I use I set a variable called file1 to our open command or our open function. I give it my temp file name and I say R for read. Now that variable is set to reading the file. And then I can use my while loop. While I can set the value of text line to read the line from this file 1, while I do that, go ahead and print that variable on the command line. And then when you're done, close the file. So very simply, we can use open to read while we're reading something, and we can set it to a value, do something here. When we're done, close the file, and that's it. So very simple sequence. There's no limit to the length of file that you can open and read with this sequence here. I have actually had files that have been hundreds of thousands of lines long, things that I could not read with an Excel spreadsheet, that I could open up and read one line at a time with a Lisp routine and grab the data and do something with it while within the Lisp routine. So very powerful, but very simple, easy to use. So let's talk about maybe another example. Let's say I want to create a function that creates a script file and then runs that script file. So in this case, let's create a command that actually will create or write a script file. So how do we do that? So I'm going to define a function or a command. In this case, I'm going to call it edit title. The first thing I'm going to do is I'm going to set file1 to opening up this text file, and I'm going to call it tempscript.scr, and I'm going to write. Then I'm going to use the write line function to write open to the file1. Then I'm going to write line my title block drawing to file1. And then I'm going to write zoom and extend. So basically, I'm going to write down everything that I would type at the keyboard into the script file. And then when I'm done, I'm going to close that file. And that file should exist that has this information in it. When I'm done with that file that I've created, I'm going to run a command called script that's going to open up this script that I created and execute what's in the script file, and then I'll end it with a print C. Now, why would I do this? There's something that I told you early on, and that is Lisp does not allow me to open a drawing and continue into the drawing and do a sequence of events. If I use Lisp to just open a drawing, once I've opened that drawing, the Lisp function ceases to continue. However, if I take and create a Lisp routine that creates a script file, and then that script file types the commands on the keyboard, it's the same as me typing at the keyboard. And so I can continue to go on and execute commands. In this case, it could be zoom. I could zoom extends. I could actually open up another Lisp routine. I could do a bunch of other things with this command. So how does this work? Well, let's go ahead and take a look at our edit title. I put it here in my startup. So there's a function called edit title. And so let's say I'm in a drawing and I really need to go and edit the title block. Now in this case, I'm going to close the title block because I had it open. So you'll notice the title block isn't open. But if I just type in edit title, and you'll notice it's already command there because I put it in the startup, and I hit that, the sequence went in and opened up my title block, and then it did a zoom extension and brought this drawing in. So not something you do all the time, but maybe there's a standard detail, or there's a certain drawing that you have to open up all the time, that or a whole series of drawings that you want to open. By using the script process, or this language of opening a file and creating a script file, you can actually create a whole series of events that can automate a whole bunch of processes or process. So I'm just using this as an example. Chances are you're not going to need a function called edit title, but I think it's a good example to show you how we can go into a drawing and then have multiple things happen within that sequence. The last and final subject that we're going to cover in this session is going over ASCII data. Now, ASCII data is the actual ASCII code for each character that is a string character. And there are cases where we need to insert a quote mark or an inch mark into a string, and we can't do it through normal methods, so sometimes we have to put the ASCII value of that character into the string. Sounds a little complicated, but let me kind of go through this, and I think you'll get a sense of what I'm talking about. So in order to understand what the ASCII value of a character is, we simply say open parenthesis ASCII, we supply a single character, and it'll return that character's ASCII value. Or if I know the value of the character, I can simply say open parenthesis CHR, give it the numerical value, and it'll return the character or supply that character as a result of this function. Now an example is if I say give me the ASCII value of a space, that value is technically 32. Now if I do the opposite, if I say give me character 32, it'll supply the return result will be a space. So how would we use something like this, and what are some of the other characters? So, character 92 is a backslash, 34 is a quote, 42 is an asterisk. Probably the one I use the most is probably the CHR 34, character 34. And here's an example of where I would do that. If you notice in the last example that I gave, we created a script file and we put the command that I would type at the command line as the write line result to the file. Now in this situation, let's say, I said this before, let's say I wanted to load a Lisp routine and I wanted to put that inside of my script file. But now here's the challenge. If I try to write line and I have 2, 3, 4 quotes in here, as write line looks at this, it doesn't understand that this quote mark is actually inside of another sequence. It thinks that that is the end of the string. And so I would not be able to just say open parenthesis load quote my Lisp quote. It would actually not give me the correct result. In fact, the routine would not finish properly. So in order to make that work, what you'll see here is I can write line and I can string cat the first part of what I need to send to that script file, which is open parenthesis load, which notice is in quotes. And then I can supply the character 34, which is the quote, then the within quotes my Lisp, and then another character 34, and then I can close with the close parenthesis for the load command, and then that ends the string cat, and then I send that to the file. So if you study this, you'll sort of get a sense of what I'm trying to do, but this is one of those quirky examples where I can't just simply use the quote marks in the way I want to when I'm writing them out to a script file. And so by string catting these forced quotes in here, it does make that function work. And so if you go up on Google and you just search for ASCII data chart, you're going to find a chart like this. And what you're looking for, the ASCII values that we use are the decimal values. And so if you notice here, the quote mark is 34, single quote is 44, and so on, equals is 61, and so on and so forth. So these are those, probably rare that you would need these, But sometimes when we're doing conversions or we're looking at things and we need to know what something is, as you get deeper into some Lisp functions, if you're especially working with any kind of character data, you might have to convert some things over to ASCII and vice versa. Kind of rare, but I thought I would cover it just so you have a reference and are able to see what types of things you can do here in writing your Lisp routines. So we covered quite a bit, a little bit more in depth this session. We talked about blocks, attributes, data extraction, extended entity data, and opening and closing files, editing files or reading files, and then a little bit on ASCII data. So I hope you enjoyed this session. In our next session, we're going to go through the dialog control language, having an interface for your programs and how to make that work. I've got some other additional commands and functions I want to cover and give you a couple more examples and some tools. And then I do have an example program that I think you might find useful. It's one that would allow you to create a quick function to publish all the layouts as PDFs in one of your drawings. And so that might be something that you'll find useful. And then we'll just we'll close it up with some best practices. So I hope you enjoyed this session. Again, if you have any questions, please let us know. Appreciate your attention, and thanks for hanging out. Take care.